Continuing on with arcs. Today is just going to be focused on adding it to a series of lines, or grid rather, in order to make a radius. So here I got a 2 1/8 inch hole, and I want to put an 1/8 inch radius on the top of that ID. We all see the CNC softwares or these desktop machines. They'll start over here and just ramp up and then down and over and down and do move over whatever you set, normally 7-10%, and just do that back and forth until that entire job's done. And there's absolutely nothing wrong with that. But when you're programming this by hand, the amount of math that would be involved in calculating all this, because like once you got to this point, you'd have to know how far down to go here, then sweep it back up here, then whatever you're doing on the other side. That would be rather time consuming. So instead, what I normally do is I just simply do a series of arcs. I'll do an arc, I'll move over to required amount, and the required amount. You can do math the long way. You can use your CAD program or whatever to know, like say this line right here, it's 6 thousandths down in the Z. Okay. I use what's called an arc calculator. They're free, they're online. I got an app on my iPhone. It's literally just called Arc Calc. It's free. There's no advertisements, no nothing. I mean, they make life easy. If you want to do the math, go right ahead and do it. I ain't got that kind of time. But like if you use an arc calculator, it will give you the overall length, meaning it'll start from the top of a circle, and whatever depth you tell it, it goes down and tells you how wide that is. So that's going to be the diameter of it. And we want just a radius. So whatever number that gives you, divide it in half, and then simply subtract that off your center line number. This is on 0 and swung 1 inch. So you'd simply subtract the number it gives you from 1 inch in this scenario to give you the correct XY as you drop down your Z. Since we're moving in, well, this first one's 6 thousandths, but after that it's 12 and a half thousandths increments all the way down, which is 10% of my 1/8 inch ball nose, which is, it's on the high side, but it's going to be fine. You could drop that down to 7% or 5% or however picky you are, you're on the finish. You don't want any cleanup or anything like that. I get it. Let the machine do the work. The only difference here is you're doing the work by manually programming it. But that's literally all this is. I'll do the arc, start up here, the arc, and then, which one's going to move me over? I think this one, yeah. And then as you can see here, I've parked up on the top Y. I move in the required amount, and then I feed the Z down to the next depth, and then just arc it around again. And then I repeat that pattern. I simply make my adjustments to X and Y for every Z step that I add in there. And you'll notice when we get down here towards the bottom, you would think this would be it, but I'm using an 1/8 inch ball nose. So the bottom half of that end mill is just that, it's a ball. So you have to go 16th thousandths deeper than what you want that to be so you can get all the way up on the side of that ball so that contours follow correctly. Now you'll notice from 125, you got to 875 on the X and Y. And it stays there because the only thing it's doing now is dropping down that additional 16th. Unfortunately, that's the only time you can copy and paste. Everything else has to be typed out by hand. And that brings me to my next thing that I haven't shown you guys about. You see how I have the spacing done in here? There's really no labeling to do because it's all doing the same process. So can't do much there. But when you separate it like this, the first two lines, well, I mean, that's Z0. But if you got a problem with the first, second, third, whatever, you can go down to that Z, and then here's its arcs commands for that circle. grbl is synchronous, meaning that all these gaps in here, like you see that little yellow line go around, some Gcode senders or some Gcode software, when there's a gap like that, it's a pause. And that almost makes you think it's a pause, but it's synchronous, meaning it'll simply skip that and go straight to that. So you can have all those gaps in there for easy readability and come back, modify things as you see fit, or you're just learning, playing, and understand, whoops, I did this wrong. So you can go back to the section that things went wrong in and fix it easily. And if you're ever curious, if you get the angle right or anything like that, all the way down here at the very bottom, probably should have scrolled in faster. This would be admitted. This here, I'm done here, I exit, O0, raise it up to my safe retract 1/4 inch above. And then I went ahead and brought it right over here to the edge of this, I think it's this one. Yeah, the edge of the start of my -1. Do it this way, it won't take about a second. And you can see up here, I'm on -1. I brought it to the negative side on the left side to be easy to see. Of course, I guess the right side would have been fine too, but whatever. That's the way I did it. I brought my Z down to 0. Very important, since this is going to be an XZ arc, I changed it from G17 over to G18. And then I simply, we're sitting at X -1, Z0, and then I moved it over to an 1/8 inch and moved it down an 1/8 inch. And you can see that, well, that's not going to highlight very well, is it? Good job, Uggs. Well, that's that little line right here. I'm sure there's some way to move this left and right. I think I got a magic mouse from Apple. I think that's probably the problem. There's probably a center button or something you're supposed to press in order to get it. But that's this line right here. That'd be nice, but actually highlighted. And it's just, I guess it's trying to. It's just hard to see. Now, easy to do that. Let's do this. And save it, and that line's fixing to disappear. There. However, you can see that line right here directly followed that contour, so you know that you got the correct radius in there. That wouldn't be something I'd leave on the machine. When you go to actually run the job, you would admit that. That's just an easy way to double check to make sure that you did everything right. You know, if these lines were shooting through it or not quite getting to it or whatever, then, you know, oops, my math is wrong, because that's easy to do. These here are all just a straight line down. That's just making sure that the ball section in the end mill, otherwise you got a ball right here, there's going to be a cusp right here where that radius of that ball is. So you have to run that all the way down here till you get to the flat sides of the end mill. An 1/8 inch end mill will be exactly half, be a 1/16. Try and keep these short and sweet. Any questions, comments, things you'd like to see? I said, and this could be, you know, it don't have to be a circle. This could be a straight line or whatever, and you could do the same process. You'd simply go to the edge of that line, bring it over, bring it down, run it across. Bring it over, bring it down, run it across, you know, until you finish the radius. This is just a lot easier method to do when you're doing everything by hand versus the computer's version where it just goes across and up and over, so forth. The math is far more involved. But anyways, hope everybody's recovering from the holidays, and see you on the next one.